Okay, so we already talked about what a mole is, so let's explore that a little further. The mole is the SI unit for a number of particles in 12 grams of carbon 12. Remember, that's called Avogadro's number. How many dots would it take for all of you as a class to make 1 mole of dots? You discovered it would take you trillions of years. That number is called Avogadro's number. 6.02 times 10 to the 23rd. It's called 1 mole, and then we relate that to the molar mass. So if you look on the periodic table and look at carbon, the molar mass of carbon is 12.01. So 6.02 times 10 to the 23rd atoms of carbon would weigh 12.01. There's other names for it: formula mass, gram formula mass, molecular mass, many other names for it, but we call it, the unit is still a gram per mole. So 1 mole, consider it like a dozen. 1 dozen is 12. If you have a dozen donuts, it's 12 donuts. If you have a dozen elephants, it's 12 elephants. If you have a dozen rabbits, it's still 12 rabbits. So if you have 1 mole of anything, it's 6.02 times 10 to the 23rd. On the periodic table, look at the molar mass. Carbon is 12.01. So 1 mole, or 6.02 times 10 to the 23rd atoms of carbon is 12.01. 1 mole of carbon is 12.01. And then if you have a gas, it occupies 22.4 liters. Okay, so this is your mole map. You can go from grams to moles to atoms, atoms to moles to liters, atoms to moles to grams, liters to moles to atoms, etc. When you use grams, use the molar mass from the periodic table. Atoms is always 6.02 times 10 to the 23rd, and liters is 22.4 liters. Grams, again, molar mass. Atoms, 6.02 times 10 to the 23rd, liters, 22.4. not going to walk you through exactly. I'll talk about this one. You're going from moles to moles to grams to moles. Now we use the molar mass from the periodic table. Multiply across, divided by the bottom. 3 sig figs. The next one, we're going from grams to moles. So grams to moles. Pathway across the top, grams to moles. Grams on the bottom. Use the molar mass for grams per 1 mole. We need 3 sig figs. Okay, this one's moles to liters. So moles to liters to moles. Liters is 22.4 liters to 1 mole. We need 3 sig figs. This one's liter to moles. Liters across the top, then moles. Liters on the bottom. 3 sig figs. Okay, this one's a little bit more complicated. So this one, we're going all the way across the mole map. Grams to moles to atoms. We're going to start with grams. Then we go to moles. Then we atoms. So we need 2 lines down this time. Units go across the top, grams, moles, atoms. Then the units come diagonally. Grams, and then moles. We're going to start with 9 grams. With moles and grams, atoms and moles, and liters and moles, they're always 1. Grams, we go from the periodic table. So we're going to look up the molar mass of potassium, which is 39.10 per 1 mole. And then atoms is always Avogadro's number, 6.02 times 10 to the 23rd per 1 mole. Multiply across the top, divide by the product of the bottom, and if you have 9 grams of potassium, you have 1.39 times 10 to the 23rd atoms of potassium. Last problem. We're starting with atoms this time. And then we're going to liters. So we're going to go next to moles and then to liters. Starting with atoms, we need 2 lines down. We have 2 arrows in our pathway. Units go across top, atoms, moles, liters. Then they go diagonally. Atoms, moles. Then we can start filling in our numbers. Moles are going to be 1. Atoms, we use Avogadro's number. Moles are going to be 1, and then we use 22.4. Multiply across the top. Divide by the product of the bottom. We need 3 significant figures.